Hi there, so we're on the P3 section now of this OCR Gateway Physics paper. This is question 11 and it's about motion and speed. It's the section about speed. First section is about a 100-meter race. Look at the table showing the time he takes to run 100 meters. Okay, so this is the distance and this is the time, and we're asked to use this information to draw a distance time graph. So I'm going to leave the data on the screen whilst you pause and have a little go at doing that. Think about which axis we usually see time on. Don't forget your correct scale, your even scale of numbers, your labels and units, and then your accurate plotting and your line. Okay, pause now. To do this myself, I'm going to have to actually zoom out slightly, so there's 100% there. Oops, too far. Okay. When you plot a graph, I suggest you always just have a little think first about your axes. My axes are going to go from 0 to 24, so how can I fit that on? That's got to be the x-axis, by the way, in this case, time, and that's got to be the y. Okay, you need to get them the right way around. Time goes from 0 to 24, so that's, I'm going to leave it as 4s because they're all multiples of 4, so I'm going to go up in 4-second increments, but that is 6 lots of 4 to get to 24. 6 times 4 is 24, so I need to draw an axis with 6 lots of 24. Let's go down to here. So let's have a little bit more room under there. Okay. So 1, 2, 3, 4, 5, 6. Obviously that's 0. So 0, 4, 8, 12, 16, 18, 24. And then up the y-axis side, I'm going to draw the axis. It's going to be a bit sketchy. So I can do it smaller with that line. Yeah, that's alright. There we go. Now my y-axis has to have the distance on it. Oops. And distance needs to go from 0 up to 100. So I'll probably go up in tens and just really see what fits. 10, 20, 30, 40, 50, 60, 80, 90, 100. No, I can't double that, so I'll go with that. Counted wrong somewhere. Now labels. This was time, and it was measured in seconds, and this was distance, and it was measured in meters. Okay, so if you've done that, you've got correct axes like that. They shouldn't be tiny and stuck in the corner, by the way. You should use as much of the paper as you can. That is worth 1 mark. So the second mark is for plotting. Go find my data. 0 and 0. This is my x. So 0 and 0, 4 and 0, 12 and 40. I'll do those 3 first. 0, 0, 4, 0, 12 and 40. And what? 16 and 60, 20 and 80, 24 and 100. 24 and 100. and then the points. So the line should go on a distance time graph. You do actually join up the points, not a line of best fit, and those accurately plotted points with a half square error for accuracy. Okay, so if it's not in the correct actual square, then it's not accurate enough, is your second mark there. Okay, let's move on. The next thing asks you to find the speed between 8 seconds and 24 seconds. So I'm going to go back to the graph because you're going to need to use that. Then you can pause and have a go in working out the speed. I will say you probably should know the equation that relates speed, distance and time, but it is also in the equation bank as well. If you're stuck, go back to have a look at that. Okay, pause it and have a go. Okay, then let's work out his speed for this question. So to work out a speed, you need to find the distance and divide it by the time it took. So the average speed, this is the equation in your equation bank, average speed is distance divided by time, and it's between 8 and 24. Okay, he has gone 80 meters in 24, take away 8 is 16 seconds. So 80 divided by 16 is 5. The answer should have been 5 with a unit on the end, please, meters per second. Only 1 mark for that though, so you need to be able to do that skill pretty fast. Next section. Brian runs the 100 meter again. This time he runs faster. So this question is all about representing a faster speed on the graph. He runs at a steady speed, so there's no pause. Draw the line for this race on the graph of the previous page and label this line faster speed. So just 1 mark again. So we're looking for a line which is a faster speed. Have a little go at that. Try and remember what the slope of a graph looks like or represents on a distance time graph. Pause it and have a go. Okay, I'm hoping that you realise that it should be a steeper line. It is only a 100 meter race, so it should really stop there, but we're only looking really for a straight line with a steeper gradient. Do you just need to label that? That was the graph for faster speed. Okay, hopefully we've got that. And just go back for the last section. Section B. I'll just zoom in again for this one. Thomas runs a different race. He runs a 200 meter race. So the distance is now 200 meters. His average speed is 3.8 meters per second. His personal best is 50 seconds. Calculate Thomas's time and decide if he's beating his personal best. So first thing is a calculation of the time, then it's whether yes or no, is it faster than 50 seconds. Again, you should probably know speed is distance over time, and you should be able to really rearrange that, but if you're struggling, go to the equation bank and you can find the equation for it there. Okay, let's check how you did then. So remember, the equation was the average speed is distance divided by time. So we can use, we don't want to work out speed, we know that, speed there. We want to work out time. So we can use one of these little triangles. D goes at the top because it's on the top of the fraction. S and T fill in the bottom. if you were covering up t, you would see d divided by s, d over s, so time is distance divided by speed. So to calculate the time, we need to do the distance, 200 meters, divided by the speed, 3.8. That will give us a time, 200 divided by 3.8, 52.631, blah blah blah. Don't really need all those numbers. I'm going to go for 3 significant figures, 52.6 seconds. Okay, is that faster than 50 seconds? No, he has not beaten his PB. For this calculation, even though there's a rearranging, 1 for the answer, 1 for no. He has not beaten his PB. Okay, let's go on to question 12.